Hi friends, welcome back. Today we're talking about proving triangles are congruent by using the side, side, side method. This means we have two triangles, and if we can prove that all three sides are congruent to each other, then we can say, hey, this triangle is definitely congruent. Before we go any further, I have some notes that I want you to write down. For these types of proofs, these notes, they may not make a whole lot of sense right now, but pause the video, write these down. It's going to be really helpful as we go along. So the first thing we want to do is, let's take a look at our proof. Kablam. All right, so given that AE is congruent to CE, AE is congruent to CE, so I'm going to go ahead and mark those down. And then we also know AB is congruent to CD. Bam, bam. Okay, so we also know that E is the midpoint of BD. Now remember, so if you go to my list here, the first thing you want to write down in your proof are your givens. The next thing you want to do are any definitions. And if you see the word midpoint or bisector, there might be a couple of others I forgot, but midpoint, you have to use the definition of midpoint. Now, so I've already written our givens here. For number 2, because I have the word midpoint here, I'm going to write the definition of midpoint. Now, what is the definition of midpoint? A midpoint creates two equal halves. So this means that BE and ED are going to be congruent. I should put 3 so you can see that a little better. Now, you got to be really careful here because remember, your similarity statements are important. So if you look up here, EAB, that's going to be EAB. We're trying to prove that congruent to ECD. ECD. So what I need to say is BE, side BE, that's from here to here, is congruent to DE. Congruent to DE, not ED. You don't want to do it that way. That's going to be your definition of a midpoint. So once I've proven that those are congruent, I can mark it on my triangle here. Now, this is great news because I have two triangles that have three sides that are the same. The corresponding sides are the same. So for this guy, we can do number 3. We can say, all right, triangle EAB. So EAB is congruent to triangle ECD. ECD. And you'll notice as we're writing that similarity statement, or I'm sorry, that congruency statement, I think I called it a similarity statement. Sorry about that. That congruency statement. Notice we did like the 1 dash, 2 dash, 3 dash, and then we did the 1 dash, the 2 dash, the 3 dash. That's really important. So these triangles are congruent because of side, side, side. All right, let's take a look at another one. Okay, for example number 2, we are given that GH is congruent to JK. GH, JK. We are also given that HJ is congruent to KG. KG. Okay, so prove that GHJ is congruent to JKG. All right, that sounds about right. So the first thing we write down are our givens, right? And now if we take a look at this, the next thing we want to do are any definitions, midpoint or bisector. I don't actually see any in here, so we're going to move on. We're going to do what I call the obvious but not givens. And these are things like vertical angles, parallel line angle relationships, and the reflexive property, okay? After that, we can do side, 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 side angle, side. We'll get to all of these, and then CP/CTC if necessary, and we'll definitely get to that in one of these videos. So, all right, so we've got our givens. Now we want to do definitions. I don't see any definitions. So now we want to do our obvious but not givens. One of these that's here is the reflexive property. You can see that JG here is going to be congruent to GJ. Now remember, again, this is vitally important that I have the right congruency statement. So over here, do you see how we have GJ? And then here we have JG. So we got to be careful. Not triangle, I'm sorry. Line GJ is congruent to line JG, which gives me, that is the reflexive property. Reflexive property. And that's to say that if we separated these triangles out and we drew them separately, we would have we would be able to say this line is congruent to this line. That's all the reflexive property is. Think of it like a shared wall, right? So if there's a shared wall in there, then we can use that reflexive property. All right, now that we've proven that that is congruent, we can go ahead and use our our congruency statement here. Triangle GHJ is congruent to triangle JKG because of side, side, side. Excellent work. Stay tuned for the rest of these, and we'll see you next time.